Hello, my name is Kartikay Goel and today I am going to explain process synchronization in Windows XP. So what we are gonna study here is why we need process synchronization, what is process synchronization, how is synchronization done in Windows XP, then we'll study wait functions, types of wait functions, then we'll discuss about synchronization objects and the various types of synchronization objects that are available in Windows XP. Then we'll see some other ways of synchronization. So why do we need process synchronization? A process or thread can run concurrently and may be interrupted at any time, completing the execution partially. The following problems occur because of interruptions and concurrency. First is the conflicting access to shared memory, second race condition, third is the starvation problem, and fourth is deadlock. So maintaining data consistency requires mechanisms to ensure the orderly execution of cooperating processes. A program may need multiple threads to share some data. If access is not controlled to be sequential, then shared data may become corrupted. One thread accesses the data, begins to modify the data, and then is put to sleep because its time slice has expired. The problem arises when the data is in an incomplete state of modification. Another thread awakens and accesses the data that is only partially modified. The result is very likely to be corrupt data. Process synchronization means sharing system resources by cooperating processes in such a way that concurrent access to shared data is handled carefully. Let us see an example of thread synchronization. There are a variety of ways to coordinate multiple threads of execution in multi-threading environment. In the figure we can see that thread 1, 2, 3 and 4 want to access a global shared variable x. Here, thread 1 takes the authority of x and thread 2, 3 and 4 are not allowed to access the global shared variable x at the time when thread 1 owns the authority of x. So this kind of activity is called locking for threads. There are a lot of ways to support how to use the shared resources such as critical sections, mutexes and semaphores, events and atomic operations. Let us see how synchronization is done in Windows XP. To avoid race conditions and other synchronization problems, it is necessary to synchronize access by multiple threads to shared resources. Synchronization is also necessary to ensure that interdependent code is executed in the proper sequence. In Windows, to synchronize access to a resource, you can use one of the synchronization objects and one of the wait functions. Each sync object instance can be either a signaled or non-signaled state. A thread can be suspended on an object in a non-signaled state. The thread is released when the object enters the signaled state. So the basic mechanism is a thread issues a wait request by using the handle of the synchronization object. When an object enters the signaled state, the executive releases all the thread objects that are waiting on the synchronization object. The wait functions allow a thread to block its own execution until a specified non-signaled object is set to the signaled state. So in this table we are shown some object types and when are they set to the signal state. For example, a process is set to the signal state when the last thread terminates. Similarly, a file is set to the signal state when the IO operation completes. A waitable timer is set to the signal state when the set time arrives or the time interval expires. Now let's have a look on synchronization objects. A synchronization object is an object whose handle can be specified in one of the wait functions to coordinate the execution of multiple threads. More than one process can have a handle to the same sync object, making inter-process synchronization possible. The following object types are provided exclusively for synchronization in Windows: event, mutex, semaphore, waitable timer, and critical section. We'll see what these object types are in the further slides. Let's have a look on wait functions. The wait functions allow a thread to block its own execution. The wait functions do not return until the specified criteria have been met. The type of wait function determines the set of criteria used. When a wait function is called, it checks whether the wait criteria have been met. If not, the calling thread enters the wait state until the conditions of the wait have been met or the specified timeout interval elapses. There are four types of wait functions: single object, multiple object, alertable and registered. So single object wait functions require a handle to one synchronization object. These functions return when the specified object is in the signal state or the timeout interval elapses. Multiple object wait functions Enable the calling thread to specify an array containing one or more synchronization object handles. These functions return when the state of any one of the specified objects is set to signaled, or the states of all objects have been set to signaled, or the timeout interval elapses. Alertable wait functions differ from other wait functions in that they can optionally perform an alertable wait operation. Registered wait functions differ from other wait functions in that the wait operation is performed by a thread from the thread pool. Now, wait functions and synchronization objects. Wait functions can modify the states of some types of synchronization objects. For example, the count of a semaphore object decreases by 1 and the state of the semaphore is set to non-signal if its count is 0. The state of a synchronization timer is set to non-signaled. The states of manual reset event, process, thread, and console input objects are not affected by a wait function. Now let's have a look on mutex objects. A mutex is a recursive log with behavior similar to that of a critical section. Operations wait for single object and release mutex are analogous to enter critical section and leave critical section respectively. A thread that calls wait for single object on a mutex is granted access to the mutex if no other thread owns the mutex, otherwise the thread is blocked. A thread releases its ownership by calling release mutex. A thread calling release mutex must be the owner of it. A thread that owns the mutex and requests access again is immediately granted access. An owning thread must release a mutex the same number of times that it requested the ownership. Mutex objects have the following additional features. A timeout can be specified on the request to access a mutex. When the mutex is created, there is an argument that specifies whether the thread that creates the object is to be considered as the initial owner of the object or not. Now let's have a look on semaphore objects. Two or more processes can cooperate by means of simple signals such that a process can be forced to stop at a specified place until it has received a specific signal. For signaling, special variables called semaphores are used. To transmit a signal by semaphore, a process executes the primitive signals. To receive a signal by a semaphore, the process executes the primitive waits. If the corresponding signal has not yet been transmitted, the process is suspended until the transmission takes place. In Windows, a semaphore object is a synchronization object that maintains a count between 0 and a specified maximum value. The count is decremented each time a thread completes a wait for the semaphore object, incremented each time a thread releases the semaphore. When the count reaches 0, the state of the semaphore object is set to non-signaled, and when the count is greater than 0, the state of a semaphore is set to signaled. Now let's discuss waitable timer objects. A waitable timer object is a synchronization object whose state is set to signaled when the specified due time arrives. A thread can use the cancel waitable timer function to set the timer to the inactive state. To reset the timer, call set waitable timer function is used. When finished with the timer object, call close handle to close the handle to the timer object. Now let's have a look on the event objects. An event object is a synchronization object whose state can be explicitly set to signaled by the use of the set event function. There are two types of event object. First is the manual reset event, second is auto reset event. The event object is useful in sending a signal to a thread indicating that a particular event has occurred. A single thread can specify different event objects in several simultaneous overlapped operations, then use one of the multiple object wait functions to wait for the state of any one of the event objects to be signaled. Now let's discuss critical section objects. The short form for critical section is CS. A CS is a Win32 version of the recursive mutex lock object. A thread that calls enter critical section is granted access if no other thread owns the CS, otherwise the thread is blocked. A thread releases its ownership by calling leave critical section. A thread calling leave critical section must be the owner of the CS. A CS is similar to mutex in all the ways except this. Unlike a mutex object, CS is not a kernel object and can't be shared across the processes. Fact that mutex objects are kernel objects means that CS may be faster than mutex. If a thread executes enter critical section on a CS when the CS is not owned, an atomic interlock test is performed and the thread continues without entering the kernel. Now let us see some other methods of synchronization. Condition variables. Condition variables are synchronization primitives that enable threads to wait until a particular condition occurs. Condition variables are user mode objects that cannot be shared across processes. Second is the one-time initialization. The one-time initialization functions ensure that this initialization occurs only once, even when multiple threads may attempt the initialization. Third is the timer queues. Timers in this queue, known as timer queue timers, are lightweight objects that enable you to specify a callback function to be called when the specified due time arrives. Some other methods of synchronization are interlocked singly linked list. An interlocked singly linked list eases the task of insertion and deletion from a linked list. S-lists are implemented using a non-blocking algorithm to provide atomic synchronization and increase system performance. Interlocked variable access. The interlocked functions provide a simple mechanism for synchronizing access to a variable that is shared by multiple threads. Another way to synchronize in Windows is synchronization barriers. So these were pretty much the ways of synchronization that are used in Windows XP. So that's all about synchronization in Windows. Thank you.